So as we know that in yesterday's class we discussed about what is magnetic flux and we found the formula. So what is the magnetic flux formula, everybody? Pi is
BA.
equal to BA cos theta. So we all know that theta is the angle between what? B and A. Is it right, all of you? Please respond. So now, and then I taught you the Faraday's experimental observations. Totally how many observations I given? 3 observations we given. Am I right, all of you? Please respond, guys. Then we are started with Faraday's first law. So what is Faraday's first law? Will says that, as I told you, I made an error there. That is EMF. That is what voltage we can say. So voltage is induced. So Faraday's first law of electromotive magnetic induction is whenever there is a, you can start from here again. So whenever there is change in magnetic flux, so magnetic flux, then whatever linked with a conductor. So if it is linked with a conductor, then 100% a voltage is produced. So if there is a voltage, then definitely what is induced? Everybody. If voltage is there, definitely something is induced. What is that? Voltage is the current will come. Am I right or wrong? If there is a voltage, if there is a potential difference, then definitely current will generate. Am I right or wrong? Please respond. So that is what. So any with a linked conductor and EMF is induced. That EMF only voltage. So EMF is induced in the conductor. So if there is a EMF, then definitely what is induced? Everybody. Current will be produced. Am I right or wrong? Please respond. So that is what. So if the conductor forms a coil, like we can say closed coil, then induced current will flow through that. If there is a EMF and the given conductor is a coil one, so then definitely what will happen? Current will induced or not? Please respond. We'll use a galvanometer and what will happen? The current will induced in it. Is it right, wrong, guys? Please respond, all of you. Nobody? Yes. So that is what. Please respond, everyone. No answer. So R, another option. What is the? This is the first definition. So what is the second definition? So when the current will induce everybody, only when it is a stagnant position or when it is a relative motion. That is my answer. That is my question to everybody. Remember when magnets keep on going inside and coming outside, going inside and coming outside. That is what we used to say relative motion. Then only the current is induced in the coil. Are you understand? Respond, everybody. Current is induced in the coil. Clear? When the magnet is goes forward and coming backward, goes forward and coming backward, then only the current is induced in the coil. Suppose if it is in stationary, suppose I kept a magnet inside the coil, does it will induce the current? Speak, involve. Simply one means let us, what is something you should decide. What is like, you don't want to speak means what I should say, you tell me. Yesterday also I'm shouting and today again I'm saying you are simply you are listen. Yes. So when I put inside, suppose I'm having a coil now, I put the magnet inside, then is there any current is induced, everybody? No. So no EMF is generated. Only when the magnet is moving, making relative motion. Am I audible? Anybody is there in the meeting? I'm
Yes,
really
sir.
frustrated. I'm saying you, please, if you are not interested, we'll stop it. No issues. You decide something. What is this? Simply it is. So only when it is moving forward and backward, whatever the pole, I may pass the south pole or I may pass the north pole. If it is moving the relative motion only, then okay, EMF is induced in the coil means current is also generated. So whenever there is a relative motion, inside, suppose I'm having a coil now, imagine. I kept inside a magnet, no current is induced or no EMF is generated. Only motion, relative motion only it will be. So whenever there is a relative motion, so between where? Everybody, between two things. What is that? Between a coil and, please respond, coil and magnet. then what is generated? A EMF is, please respond. EMF is induced in the coil. Means in the sense of what? Coil become what? Conducting. Okay, so current is induced in it. That is what. Or you fix the magnet. You fix the magnet, okay, whatever the pole, and you can move the what? You can move the coil forward and backward. That is what. There must be relative motion between coil and magnet. Or magnet can go and come back, go and come back. Or coil can go forward and move back. Then also induced current. Current is induced. Do you understand, Sai, what I'm saying? Or speak, say understood or not ready to speak, please go. Please don't make me to beg more than this. I don't want. Okay. So now what is happening, everybody? If there is, imagine for example, if north pole of a magnet is going into the coil, then definitely EMF is generated. So flux, then suppose if immediately you take away, then what is happening? Direction of magnetic field is reverse. Then the current is also what? Reversed. Is it right or wrong? Please respond, guys. That is what.
Yes, sir.
So, and the induced EMF, whatever it is there, the induced EMF, okay, so acts only along as long as the change in magnetic flux. So if the magnetic flux is reversed, then EMF also will be that EMF will be disappears and it will be again generated in another direction. That is what the induced EMF acts as long as the change in flux is taking place. So once the change in flux is changes, the EMF direction also will be. That's what the induced current also will be changes. That is only the first law, Faraday's first law. So then second law is very important one. So what is second law, everybody? Faraday's second law. What is Faraday's second law? Yesterday also we discussed. Everybody, Faraday's second law. So that is what we can say. So a Faraday's second law, particularly about EMF. The symbol of EMF will represent with the E. So what will say is the magnitude of induced, how much EMF is produced. The magnitudes of induced EMF, is directly proportional to, for whom, everybody? Please respond. Rate. Rate means what? Immediately you should remember. From 9th I'm teaching you. Rate means what? With respect to, please respond. With respect to time.
Time, sir.
Directly proportional to rate of change of magnetic flux. Rate of change of magnetic flux. So that is what. So what is that? E is directly proportional to. E means what? EMF. So EMF is directly proportional to change in magnetic flux rate. Rate means with respect to time. So this is delta. Delta means what? Particular or total, everybody? Total. Am I right or wrong? Open your mouth, yes. So that is what. It is belongs to the total. Total means what? Average. Average EMF is equals to, so constant. So we all know that K value will consider, okay, 1. So K value delta into pi divided experimental value, please. Experimental value is 1. So delta pi by delta t. So this is what is actually, if you notice it, it is total actually. Total means average it is. So it is delta is not for D means particular part. At that instant. Delta means what? Total. So that is what we say is EMF, average EMF is equals to mod of delta pi divided by delta t. That is what you have to remember. So at that instant, what will happen? That is what I say is E instant. What is going to happen? EMF which is produced at that instantaneous. What is instantaneous, everyone? Which is equals to what? Mod of delta pi by delta t. Is it right or wrong? Please respond, guys.
Yes,
At
sir.
that instant. But what is the actual formulas, everybody? What is the actual formulas? They are actually magnitude. Magnitude positive or negative or mod, if you put it will turn up into positive. But what about the actual formulas? Minus of delta pi by delta t. Same way this one is what? Minus d pi by dt. They are the actual formulas. And this is magnitude. Magnitude mod positive or negative, it will be what? Positive only inside the magnitude. Now, so in this case, so if the induce the coil having a resistance R, the coil, okay, resistance of coil who is having R ohms, then what is the induced current? Understanding? So the induced current whose the coil having a resistance R, which is equals to, so we all knows that average current is equals to, what will happen everybody? E average induced EMF divided by R. Is it right or wrong? Please respond, guys.
Yes, sir.
Resistance law, we all know what is the formula, Ohm's law. I is equals to V by R. Yes or no, guys? Here V means what? What do you mean by V here? EMF only. Yes or no, guys? EMF,
Yes,
voltage. Yes. So R. R means what? Radius. Sorry, resistance. R. So then we all knows that. So I average, the induced current is equals to, what is the E average formula? Check it, everyone. This one I can write E average into 1 by R. So what is the E average we got? Induced, average induced one. Delta pi by, speak everybody. Delta pi by mod of, no
delta
answer.
t.
Delta pi by delta t into 1 by R. So this is what is the induced current. Okay, everyone. Same way, at that instantaneous, what is the current generated? At that instantaneous. So what is going to happen at that instantaneous? E instant divided by R. So means E instant. E instant is what? Delta pi by, sorry, d pi by dt into 1 by R. Is it okay, guys, everybody? So this is only Faraday's second law. I think up to here we studied, and I given you an example also. Am I right, all of you? Please respond. Yes, that's
Yes,
right.
sir.
Please join fastly. All of you understand?
Yes, sir.
Make it. So next, I got one example. Am I right, guys? Yes, please. Any doubt? Anybody can ask me. Clear, everyone? All of you?
Yes,
Yes,
sir.
sir. Yeah. So next. So now, to study this direction of this induced current, induced EMF. So that is what we'll use a law, call it as Lenz law. Okay. So for before that, that numerical once again, I think have you all solved the numerical? I want response. Yes, please respond. So numericals, anybody having any doubt, you can ask me. Sai, Rishi, Pradeep, yes, Mr. Kevin, Monish.
No doubt, sir.
So right next. So all of you keep it. Direction of induced EMF. Sir, what is the direction of this EMF? We have to find it. Or current, whatever. The direction of induced EMF or current, we'll use a law, call it as Lenz law. What is that? Lenz law. So write it. Any doubt? So proceed now. All of you. Monish? Yeah. So keep reading. Is it visible, guys? Please respond, everybody.
Yes, sir.
So right. Direction of induced EMF. Direction of induced EMF or current. So what is the law we'll use, everybody? Lenz law. Okay. Have else anything studied about this Lenz law? Yes, brothers?
Yes,
Monish,
sir.
what is studied? Yes. Tell me. Sai? Hey, anything, whatever you studied, tell. Yes, Monish? No answer? No, brothers? Okay. So, right. The direction of induced current. Definition. What is the direction of induced current? Right. The induced EMF. The direction of
Sir,
induced
when
EMF
North Pole is,
is,
sir,
yes, brothers, is
sir,
always
when
such.
magnet is moved to, sir, that the coil in
Hmm.
North Pole, it becomes North Pole, sir.
Oh, I'm not understand. Okay, that's fine. Whatever you studied, so we'll see that.
Today only,
What is studied? Tell me. Yeah.
sir, when the bar magnet is made close with that circular coil, it goes in anti-clockwise direction, sir. So it becomes as north and other will become south, sir.
Okay. Then other thing. Anything? Princey? You? Princey is there? Yeah, Kevin. Yes, Kevin. Others? Oh, tell me, brothers. So okay. So this is what is studied?
Yes, sir.
Yeah. Okay then. So now you see the difference. Okay. So now write the definition. I'll explain. You listen to this. The direction of induced EMF is always such that it opposes the cause producing it. So means in the sense of whomever is responsible for producing EMF. So the direction of EMF is what? Same direction or opposite direction? Everybody. Opposite. Opposes. Understand everyone? That is only called as direction of EMF. So whomever is responsible for production of EMF. Am I audible, everyone? Whomever will takes the responsible for production of what? EMF. So the direction of that one is always opposes the cause of that producing one. Are you clear, everyone?
Yes,
Yes.
sir.
Yes. So that is what it is call it as Lenz law. So once you will start solving, you'll understand. So let me take several examples continuously, you'll understand. Imagine now a magnetic field is acting inwards. The direction of magnetic field is what, everybody? All of you? Inwards.
Inwards.
And this is the increasing magnetic field. What is that, all of you? Increasing magnetic field. So be focused. Any doubt, small doubt also ask me. So I have been placed a coil now. Okay, this is my coil. Okay, all of you. Now, B increases. We all knows that B increases means what will increases? Magnetic flux also. Please respond. Magnetic flux increases. Magnetic flux increases. We all knows that. What will happen? EMF will be.
EMF also increases.
EMF induced. EMF induced means definitely what will induce? Current will
Current is
induce. So once if EMF is induced, then what will happen automatically? Pi will. Magnetic flux will what will happen? Everybody. If EMF increases, magnetic flux will what? Decreases. Yes or no, guys? All of you? See, magnetic field increases, magnetic flux increases. Magnetic flux increases, EMF is going to induce. If EMF is induced, then magnetic flux is going to what? Decrease or increases? It is going to be decreases. Do you understand what I'm saying? Please respond, everyone.
Yes, sir.
So, when magnetic field increases, so what is going to happen, everybody? Magnetic flux also increases. Magnetic flux increases means, see that, apply the right hand thumb rule now. All the direction of magnetic field is our thumb, and direction of current is our direction of current. So current will be induced in what direction? Clockwise or anti-clockwise? Everybody. Up to here you can see. Clockwise or anti-clockwise? No answer. Clockwise or anti-clockwise, guys? If B increases, magnetic flux also increases. Am I audible? Respond, everybody. Yes? No one answers.
Yes, sir.
Yesterday we studied formula. What is the formula, brothers? E is equals to B into pi into 2R. Do you remember? 2R into dr by dt. Yes or no? Numerical solving. Check it, everybody. Magnetic flux, everything. Numerical formula. Anybody remember?
Yes, sir.
Yes. So remember, all of you, if B increases, because this is increasing one, so pi also increases. Pi means what? Magnetic? Say, guys, what is pi? Yes. Pi
Magnetic
what? What is pi? Magnetic
flux.
flux.
Magnetic
So
flux.
magnetic field increases, magnetic flux also increases. Number of field lines passing through that increases. So now if I apply the right hand thumb rule, understanding. So all my curled fingers, the direction of magnetic field is the direction of thumb, and all our four fingers are curling. So it will be clockwise. But once the EMF is induced, now EMF is induced in the sense of what is going to happen? So magnetic flux increases, current is going to induce. That is what? Or we can say EMF is induced. Once EMF is induced, what is going to happen? Immediately, everybody should answer. EMF is induced, what is going to happen? Again, magnetic flux is going to decreases. No, open your mouth. Decreases means in the sense of it is acting the direction of induced current. It is decreasing, guys. Decreasing means what? Opposite to the who is cause of this? Who is cause of this induced current now? Everybody. Who is cause of this induced current? Please open your mouth. Who is cause of this induced current? B. Are you understanding? Who is cause of induced current, guys? B is the cause of it. Am I right or wrong? So the opposite, the direction of induced EMF is always what? Such that it opposes the cause of producing it. Means it will act what direction? Suppose if it is clockwise, same direction it is acting. Now if it is anti-clockwise, because EMF is acting opposite to the cause of producing. So what is the direction of induced current now? Clockwise or anti-clockwise? Yes, please. Yes, respond. Clockwise or anti-clockwise? Anti-clockwise. The induced current will goes anti-clockwise direction. Now you apply the right hand rule. All four fingers is direction of induced current, and your thumb is acting, you see, away from the magnetic field or towards the magnetic field. Please respond. No answer. Away from the magnetic field or towards the magnetic field? Are apply speak any what? You want to be silent? I'm really serious, I'm not going to be normal with this. You apply it and tell me. If not able to understand, you tell me again. I'm saying. So what is the formula? The direction of induced EMF is always such that it opposes the cause of producing it. So suppose if the EMF is the current is producing is clockwise. If the current is producing is clockwise, then the magnetic field is acting in what direction? Into the page. Into the page means what? Same direction of B. So same direction of B means it is going to increase. But here it is acting opposite, decreasing. So it is decreasing. Suppose if the pi is increases, then it is clockwise. If the pi is decreasing because of induced EMF, so it is acting opposite to the B. So it is what? Clockwise or anti-clockwise? No answer. Clockwise or anti-clockwise?
And
Anti-clockwise. One more example I'll explain. Now second one, let me take. So for example, try to understand everybody carefully. Now I'm putting a dot. Dot means what? Inwards or outwards? Everybody. Inwards or outwards? Please respond.
Outwards.
This also don't know means then I should need to I need to just feel myself ashamed it is. So inwards or outwards, everybody. This is the direction of magnetic field. What is that? Inwards or outwards?
Outwards.
Outwards. So again, it is increasing magnetic field. So B increases. What is going to happen, everybody? Magnetic flux also. Open your mouth. Magnetic flux also increases. If magnetic flux increases, then what is going to happen? All of you. Yes, please. EMF is going to. EMF is going to what? Induced. That is what? Current is going to induce now. If current is going to induce, then automatically what is going to decrease again? Magnetic flux is going to. Please respond. Magnetic flux is going to decrease. So now imagine, I have kept a coil now, a rectangular coil. So magnetic field is increasing. So definitely the magnetic flux also increases. Magnetic flux means what? Number of field lines passing through it is increases. But once the current is induced, then again magnetic flux is going to decreases. Means in the sense of, now you apply your right hand rule and tell me, induced current EMF, automatically pi value is going to decreases. So means now clockwise or anti-clockwise, everybody. You tell, then I will assess. Yeah, please. Suppose if it is anti-clockwise, imagine the induced current is anti-clockwise. I dash. Now tell me, either it is magnetic field is going to increase or decrease. Check it, everybody. The magnetic field is also acting outwards, and the induced current, now magnetic field is also outwards. But we all knows that what is the definition? The direction of induced EMF is always such that opposes the cause of producing it. So who is cause of producing this induced current? B. So now B is acting outwards, means this direction of induced current, the magnetic field produced by it is acting same direction of it or opposite to it? I'm asking Sai. Yes, Pradosh. Can I explain once again?
Yes, sir.
Or at least say that. Because I know it is, if you are not doing anything, then what I can do? Can I explain once again? So all of you observe very carefully. At least for that you say yes, Ra. What try people? Myself,
sir.
I feel ashamed as it is. Hurry, not understand, say, I will say correct once again. Simply sitting like a dummy fellows and all dumb fellows. What is happening? At least you don't know. Not understand, sir, not understand. You tell me again, I will try. Again, I will try to explain another ways. Simply sitting, what is this? I don't know what you people are thinking it is. So the definition of Lenz law is the direction of induced EMF, whatever it is. So you imagine the direction of EMF because of some reason, because of increasing magnetic flux or because of magnetic field or because of whatever. If the EMF is induced in a given coil, the direction of it or current, whatever, is always such that it will opposes it. Means if the induced EMF is acting because of B, if the B is acting inwards into the page, then EMF will act out of the page. If B is acting out of the page, then induced EMF will act what? Into the page. Do you understand?
Into the page.
That is opposite. Who is reason behind? Imagine, for example, suppose if I want to use a statement, I says a kid kills a father. A kid kills a father. So generalize says, so a kid is actually the reason behind what? Kid father. So the kid, whomever is cause for the producing that, so that person is opposing him, means he is acting opposite to him. That is what is called it as Lenz law. So the induced EMF always opposes the direction of cause. Whomever is the responsible for the EMF, he will start opposing him. Means he will act opposite to him. He will act left side, that EMF will act right side. If EMF is acting right side, that person will act left side. That is what I am saying. Nothing else is there. Are you understand now?
Yes, sir.
Yes?
Yes, sir.
That's why. So now in first case, what is going to happen? What is the direction of magnetic field? Everybody. What is the direction of magnetic field?
Out.
Into the page. Outwards. This is what you are studying. Cross means what? Into the page or out of the page?
Into the
Into the page. Clear? Now, I have been placed a coil now. So B is increasing. I'm mentioning that B is what? Increasing or decreasing? Magnetic field is what? Increasing. So magnetic field increases, then definitely the number of field lines which is passing through the coil, that is what? Magnetic flux will increases. Am I right? Yes or no?
Yes.
Yes. So magnetic
Yes.
field magnetic flux increases, then definitely what is going to happen? EMF is induced in the coil. Do you understand, everyone? Or current is induced in the coil. So imagine that, for example, I will take. So this is what is the direction of magnetic field. Imagine, for example, the current is induced. This is a clockwise direction if I have been taken. So now this is the direction of induced current or induced EMF. So we all know that EMF direction, because magnetic field is into the page. So means EMF direction must be what? Opposes, means opposite to it. Means outwards or inwards? Outwards or inwards? Outwards. Are you clear? Because magnetic field is the cause behind this EMF. So the EMF must opposite to the direction of magnetic field. So magnetic field is acting into the page. So EMF direction is what? Out of the page or into the page? Out of the page. So out of the page means the induced current will go clockwise or anti-clockwise? Everybody. Yes, please. You are applying right hand rule. All the four fingers is direction of induced current. Now you can see your thumb is acting what? Opposite to the magnetic field or towards to the magnetic field? Opposes. Outwards it will come. So outwards means it is a what? Clockwise or anti-clockwise? It is
And
anti-clockwise. Now, here what is the direction of magnetic field? Everybody. Here what is the direction of magnetic field? Out of the page. Is it right or wrong? Yes? Please.
yes, sir.
Yeah. Now, because of this, what is going to happen? Magnetic field is increasing. Again, I'm giving increasing, no constant decreasing. Magnetic field is going to increases. Increases means pi is going to what? Magnetic flux is going to what? Please respond. Magnetic flux is going to increases. Magnetic flux increases. See, remember, current is induced when magnetic flux increases or decreases, whatever. So now, pi magnetic flux increases. Magnetic flux increases means what is going to happen? EMF is going to what? Induced. If EMF induces, then again what is going to happen? Flux is going to decrease. So now flux is going to decrease means what? It is acting opposite to it. So opposite to it means what direction? Clockwise or anti-clockwise? Direction of EMF. Now again apply right hand rule. Now you tell me. So what will happen? I have to apply the induced current direction is what? Clockwise or anti-clockwise? It will be
Clockwise.
clockwise because magnetic field is outwards. So induced current, induced EMF will be into the page. Are you clear, everyone, now? Yes? Please respond.
Yes, sir.
Right. Apply. If I apply, it will get it. Now, for example, imagine a straight conductor is there. I current is passing. So let me take this current is increasing. This current is what, everybody? Increasing. Now tell me, what is the direction of magnetic field at this point? Apply right hand thumb rule now. Thumb rule. Current direction is direction of thumb all over four fingers. At this point, it is acting what? Into the page or out of the page? Everybody. At this point, please respond. Are right hand thumb rule, ra? Into the page or out of the page?
Into the page, sir.
Into the page. Okay. Now I have been placed here one rectangular coil where a distance away from it. We all knows that when we are moving away from the conductor, magnetic field decreases or increases?
Decreases.
Decreases. Okay. So see, if not understand, you tell. I will try in another ways. You all knows me very well. Same concept, multiple ways I will teach you. But certain level you will definitely understand. It's not necessary that everybody will understand the first time. So now, at this point, you tell me what is the direction of magnetic field? Curl your fingers. So now square,
Sir,
one square box.
Sir, out of the
Page. Others also respond. So out of the page. So that is what is the direction of current here. Am I right, everyone? Please respond, guys.
Yes,
All of
sir.
you? Yes. Now, it is increasing. Increasing means what is going to happen? We all knows that. Magnetic field is directly proportional to what? Speak loudly. Magnetic field is directly proportional to what? I. Am I right or wrong?
Current.
So yes. So I is going to increases. I increases means what is going to happen? B also.
Magnetic field also increases.
Magnetic field also increases. Magnetic field increases. Then what is going to happen? Magnetic flux also.
Increases.
Magnetic flux also increases. Magnetic flux increases. Then what is going to happen?
EMF is increased.
Induced current. Current is going to induce. If current is going to increase, immediately what is going to happen? Pi is going to be.
Is decrease.
Yes. So pi is going to decreases. Then immediately what is going to decrease? Yes, magnetic field is
Magnetic
going to decrease. Means, now can you tell me what is the direction of it? Now it is acting. So the direction of magnetic field is outwards. So what is the direction of induced current? What is the direction of induced current? Opposite to it, guys. So it is what? Clockwise or anti-clockwise? It will be, yes. This is outwards. This is outwards. So outwards means it is acting what? Decreasing, Ra. It is decreasing. So pi value is decreasing. Pi value decreases means after induced current, pi is decreasing. So means it has to act what? Opposite to it. Now magnetic field is outward. So induced current. What is that EMF direction? EMF direction is into the page. Am I right or wrong? So into the page means what? Clockwise or anti-clockwise? Apply right hand rule now. All four fingers is direction of current. All four fingers is direction of current. Understanding? So your four fingers, if you apply towards your right hand, you stretch and you apply. See that your thumb is acting what? Into the page or out of the page? Yes, please. Into the page. Am I right, guys? That is what. So we all know what is the formula. B formula. Can you tell me B is equals to magnetic field formula equals to mu naught divided by 4 pi into 2i by a means B is inversely proportional to what? A. We all know, just now I said, am I right? When you are moving far away
Yes.
from it, magnetic field is going to decreases. Understand now this one, everybody?
Yes, sir.